Okay, let's get started on Chapter 8, Section 4. This is involving solving equations and applied problems that involve decimals. All right, so not a lot of new stuff. Only thing that's kind of new here is just the fact that we're kind of incorporating decimals into the problems, which, I guess can be a little bit more challenging, I think. But it still involves the same, conventions that we use when we're solving just regular equations. So solving equations involving decimals. So what we're going to do is start off here. Let's clear, first thing you want to do is you want to clear parentheses by using the distributive property. There's kind of ways around that, but I would say that's a pretty good rule to kind of follow. If needed, if it presents itself, combine like terms. If you have like terms that you can put together, and collect them and add them or subtract them, do so. All right. And get variables and constants, okay, on opposite sides. So get variables on one side. That's important. Okay. And always check your solutions when you are finished. All right, so on this first example right here, we've got a y minus 6.7 is equal to 4.64. So we're just following the same old inverse operations we always know how to do. So we're going to add 6.7 to both sides, right? On the y side, the 6.7s cancel right there. Those are inverse of each other. And now we just kind of make it equal. So right here, it's 4 plus 0, and then 13, and then that's going to be 10.34. All right. Okay, right here, we can clear parentheses by distributing. So we can distribute the 3. So you get 3 times x is 3x. 3 times 1.3 is going to be 3.9. So minus 3.9 equals 9.3. All right, and then add 3.9 to both sides. Add 3.9, and then rewrite it. So now we got 3x equals, and then 3 plus 9, that is 12. And then we got what, 13.2? All right, and then just divide by 3. Divided by 3. So you're just doing 13.2 divided by 3, which is 4.4. All right, moving on to this one right here. All right, let's clear the parentheses. Let's distribute the 5. Distribute the 5. So we get 15x minus, and then 5 times 0.2. Well, 5 times 2 is 10. So 5 times 0.2 is actually 1, right? I'll write that as a decimal, though. Equals 9x minus 13. All right, I'm going to subtract 9x. I'm going to get the variables on one side. Right, those cancel out over there on the right side. And now we've got what? We got 6x minus 1. I'm sorry, 6x minus 1 equals negative 13. And then we're going to add 1 to both sides. Adding 1. And then we've got 6x equals negative 12. And the last step is going to be to divide by 6. All right, and so you got x equals negative 2 on that one. All right, right here, solve these application problems. So we just got to read through this. We've got Anaconda, I remember I was playing around with the names here, buys $31.48 worth of gas for her car if the gas station charges 2.539 cents, $2 and 539 thousandths of a dollar basically per gallon. How many gallons did she get? Round to the nearest tenth if needed. All right. So for this one, Yeah, so what do we do? How many gallons did she get? Well, we can just kind of set it up as an algebra problem. We can set it up like this: 2.539 times n. N is the number of gallons that she purchased, and then make that equal to the total, which was $31.48. Okay. So a lot of you probably, even when you, before you and I started writing all this down, you're like, well, I'll probably have to divide to solve this, but that's how this equation is solved. So just be able to, make an equation out of it, regardless of knowing how to solve it. You should be able to make it into an equation. So we're going to divide that by that. And that makes sense, by the way, that um, that's what it'll cost per gallon. Because I don't know if you ever noticed at a gas station, there's always a 9. They always kind of put a 9 that's raised up. It looks almost like a power, but they always put a 9 there so that you have to round up. But I'm going to do that. So we're going to do 31.48 divided by 5.539. All right. It says round to the nearest tenth. All right, so when I do this, I get, on my calculator, I got 5.68336, just kind of goes on. But we just have to round to the nearest tenth. So we're rounding that place value right there. So that rounds up because it's next to an 8. So 5 or more raise the score. So Anna bought about 5.7 gallons. All right. In 1 week, Doug Graves worked 35.75 hours at the cemetery and earned $245.75. How much did Doug earn per hour? Round your answer to the nearest cent. So again, we can do this one. Let's do 35.75. N is the number of hours, and make that equal to 247.75. And then we can just solve this by dividing. I think I called that the number of hours. The N is the amount of pay. Pardon me for not saying that the right way, but yeah, that's the amount of pay. So we're going to do $247.75 divided by the amount of time. All right. So when I do this, all right, I got 6.9300, and it just keeps going. It's not repeating. Well, it does repeat, but it doesn't repeat up until like a few digits in. But we're rounding that digit. Well, it's next to a 0, so it's a no-brainer there. That's just going to stay a 3. So Doug's pay is about $6.93 an hour. All right, not the greatest pay there. All right, not even minimum wage. All right, suppose you have $11 in nickels and dimes. How many of each coin do you have? If the number of dimes you have is twice the number of nickels. All right, so the number of dimes is twice the number of nickels. All right, so let's say this one. Okay, so what you want to do on this one is, all right, so there's, what does it say? How many, if you have twice, the number of dimes is twice the number of nickels. All right, so let's make 0.05 n the number of nickels. All right, so because a nickel's worth 5 cents, 0.05, so that's the decimal equivalent of it. And then plus 2 times the number of dimes. So we're going to do 2 point, Let's do 2n, 2 times the number of dimes. We'll do it like that. See if this works. And then make that equal to $11. Let me just clean this up a little bit. So 2 times 0.10, that's going to be 0.2 equals 11. And then adding that up, we get 0.25n equals 11. And then we just have to divide both sides by 0.25. And then that's going to be n equals what? 44? All right. So that one, all right. And then for this one, for D, Jesse and Julie bought a rectangular building lot in suburban Chicago. And we've got decimals for the dimensions. So we're just looking for area. Now, area is just length times width, right? That's it. So this is not to scale what I'm doing here. You got this times this. And then we're just going to multiply them. 113.4 times 87.4. And then it's 9,911.16 square feet.